Hello everyone, welcome to textmostudy.com. Let's solve a problem based on application of first theorem of Castiglione. The question is, the bend ABC shown in the figure carries a concentrated vertical load B at A. Find the vertical and horizontal deflections of A. Assume flexural rigidity. This figure is given the question and we are asked to solve the vertical and horizontal deflection of E. Here there is a vertical load P acted on the free end A. Now let's calculate the moment. This is the same figure that is given in the question. Now we have to calculate the moment. The moment from we will get two moments, that is moment at AB and moment at BC. Moment at AB will be P into the distance x from the free end, that is Px, and the moment at BC we will get P into A. P into the perpendicular distance, that is A. Now let's calculate the strain energy. The formula of strain energy is m square ds upon 2EI. As we have two moments, we need to calculate the strain energy at two parts of the bend. Here we will take the limit from 0 to A, and here we will take the limits from 0 to H, because here the height is H and here we will get the moment, that is PA, and here we will get the distance 0 till here, that is H. The limits we have already put. Now let's put the value of the moments. We will get Px whole square ds upon 2EI. And here we will get Pa whole square ds to EI. Let's put this way. This will be dx and this will be dy. Now in calculating it, we will get P upon 2EI. Let's bring it outside. And here also we will get P square 2EI, and let's bring it outside. Now let's bring A square also outside. And take from 0 to H. And we will get x cube upon 3 0 to A. This is P square A square 2EI. Upon integrating dy, we got y limit from 0 to H. Now on putting the value of x as A, we get A cube upon into 3, that is 6. Here we got P square A square. On y we put the value, that is H minus 0, that is H, on 2EI. Now final value we got P square A cube upon 6EI plus P square A square H upon 2EI. Now integrating it, we will get, now taking LCM, we will get 6EI. Here P square A cube upon 3 P square A square H, and now by taking common we got 2a plus 3h. Now this is the strain energy we got. Now let's calculate the vertical deflection. The formula of vertical deflection is partial derivative of strain energy, that is Wi upon del P, because here the load given is P. Now the value of Wi was P square A square 6EI whole into A plus 3H. Now partial derivating it, we get 2P A square upon 6EI A plus 3H. Now cancelling it with 2, we get P A square 3EI whole into A plus 3H. This is the vertical deflection we got. Now let's calculate the horizontal deflection. To calculate horizontal deflection, let's introduce a horizontal load Q at point A and value of Q is 0. Now let's calculate the moment. The moment we will get is, this is the structure that is given in the question. Here we introduce the horizontal force, that is Q, where the point is A, B and C. Till here the distance we will take is x, here that is y, and the length here is h, and here the length is A. Now we will get moment. So the moment at AB is P into x, and the moment at BC is P into A plus Q into Y, and both have same direction, that is anti-clockwise direction. Now let's calculate the strain energy. Strain energy at AB plus strain energy at BC, and the formula of strain energy is m square ds upon 2EI, and here it will be AB for AB, and here the moment will be for BC, m square ds upon 2EI. For AB the limits will be from 0 to A, and for BC the limit will be from 0 to H. Now let's put the value of m AB, that is we get Px whole square dx upon 2EI, limit from 0 to A. Here moment BC will be PA plus QY whole square dy upon 2EI, limit from 0 to H. We will keep it like this for easier calculation of horizontal deflection. Now let's calculate the horizontal deflection. The formula of deflection is partial derivative of strain energy, that is del Wi upon del Q. Now this term will be 0, and by integrating it we get 2A plus QY whole y dy upon 2EI, division from 0 to H. 2 got cancelled. Let's bring EI outside, and let's separate these values, and let's separate these terms. We will get PAY plus QY square dy 0 to H. Now let's separate these two terms. We will get integrating it, we will get PAY square upon 2 plus QY cube upon 3. Now let's put the value of phi. We will get PAH square upon 2 plus QH cube upon 3. Now as we know the value of Q is 0. Now this term will be 0. Now we get PAH square to EI is a horizontal deflection. If you want, you can note it down. Thank you.